सर इंट्रोडक्शन जो देंगे वो पूरा ही बिना देख के बताना है कि थोड़ा थोड़ा देख भी सकते हैं?
देख के बता दीजिए और क्या। नीचे आपको पेपर रखते हैं।
हाँ हाँ।
और वीडियो आपका कैमरा सिर्फ फेस तक यहाँ पकड़ ऐसा पकड़ दीजिए तो देख के पढ़िए, बिना देख के मत पढ़िए, गलत होता है ना।
ये very good morning to everyone. It gives me immense pleasure to extend a warm welcome to etc. etc. अच्छा, Malla Reddy College of Engineering is the jewel in the crown of Malla Reddy Group of institutions was established etc. etc. up to this. Okay. Then मैंने दिया. Now first and foremost I would like to express my heartfelt gratitude to our respected principal sir Dr. M. Asif, who was always has been a beacon of support and encouragement for all our academic endeavors. I would also like to thank our Honorable HOD Ma'am Dr. Sneha Joshi for our unwavering commitment to the positive culture of etc. etc. Then today we are privileged to have etc. our guest speaker. Okay, फिर मैं मैम को ट्रांसफर कर
बस
ठीक है.
बढ़िया। सरिता मैडम, सरिता मैडम। क्या protest है? हम्म, अच्छा अच्छा, ये क्या है, किसी को बुलाने ना देता।
எல்லாம் கொடுத்துருப்பாங்க நினைப்பேன். கொடுத்துருப்பாங்க அதை நீங்க சொல்லுங்க. இல்லைங்க சார், அது கான்டாக்ட் வச்சுக்கிறது.
Am I audible to everyone?
அதாவது ஒரு திறமை வேணும்ல.
ராஜேஷ் குலா ஆம் பேசுற மூணு நாலு பேருக்கு ரெகுலர் கான்டாக்ட். நான்லாம் பார்த்துன்னு வச்சுக்கோங்க, எல்லாத்திட்டையும் பேசுவேன். மூணாதான் வருவேன். இதெல்லாம் யார்கிட்டயுமே சேர மாட்டான். இல்லை என்கிட்ட மட்டும் பேச இப்போ நாய் போச்சு இல்லை
அந்த மாதிரி
சைக்கோ தான் வேலாம். கொரோனாவால் தான் பாஸ் ஆனா இன்ஜினியரிங் போட்டு வேண்டவே
వైప్ అవుతుంది అతను కంట్రోల్ చేస్తారు వాళ్ళు ఎవరైతే అన్ని
நம்பிக்கிறேன். எல்லாம் அட்வைஸ் கொடுத்துருக்கான்.
சந்தோஷம் பேசுறது.
मैडम you can start.
So our session is about to start. Uh, Please join everyone. So we will start our session at dot 10:30.
नहीं ले रहा। वही घूम रहा है तो उसके बाद आने को
So those who are unable to join in this Google Meet, so they can join in the our YouTube session as well, YouTube live session as well. The live link is posted in the WhatsApp group. So once again, I'm telling those who are unable to join in Google Meet, they will join the YouTube live session as well. YouTube live link posted in WhatsApp group. So I'm telling those who cannot join Google Meet, they can join the YouTube live session as well. Okay, that YouTube live link is posted in the WhatsApp group. So, a very good morning to everyone, my esteemed colleagues, distinguished guests, and dear participants. It gives me immense pleasure to extend my warm welcome to all of you to this faculty development program on current trends in materials and their applications. I am Dr. Shomita Jana, Assistant Professor in the Department of Physics here at Malla Reddy College of Engineering, and I'm honored to host this significant event. Our Malla Reddy College of Engineering is a jewel in the crown of Malla Reddy Group of Institutions. Was established in the year of 2005 with the approval from AICTE, permanent affiliation with the approval of JNTU
and accredited by NBA and NAC. Our college is located at Maitamaguda Dhulapalli, which is situated in Secunderabad, Telangana, India. Our institute offers BTech courses in computer science and engineering, then data science, art foundation, and has ever since been excelling in every aspect. Now, before starting our FDP program, first and foremost, I would like to express my heartfelt gratitude to our respected principal sir, Dr. M. Aso, who has been a strong support and encouragement for all of our academic endeavors. I would also like to thank our Honorable HOD Ma'am, Dr. Sneha Joshi, for her unwavering commitment to fostering a culture of continuous learning and professional development. Today, we are privileged to have with us an eminent scholar and distinguished guest, Professor Balaji R. Ravuri. Your pioneering research and profound insights into the field of material science has been inspiration to many. We are eagerly looking forward to see your presentation, sir. And also, this program is a wonderful opportunity to all of us to about this development, exchange of ideas, and gaining our experience. So once again, I am heartily welcoming to everyone. And also, before we proceed, my fellow colleague, ma'am, respected G. Radhika, ma'am, she will give a brief introduction about our eminent guest, Professor Balaji. Thank you, everyone.
Thank you, me. Hello. Good afternoon to everyone. Myself, Radhika, Assistant Professor of Physics, Malla Reddy College of Engineering. It is my distinct honor and privilege to introduce our esteemed guest speaker, Professor Balaji Rao Ravuri, for today's FDP program on current trends in materials and their applications. Professor Balaji Rao is a highly respected figure in the field of material science. Professor Balaji Rao completed his MSc, MPhil, PhD from Acharya Nagarjuna University campus, Andhra Pradesh. He completed his postdoctorate from Georgia Institute of Technology, USA. Currently, he is working as an professor and head department of Nanoscience and Materials, Central University of Jammu, India. Dr. Balaji Rao Ravuri focuses his research expertise on inexpensive materials for sodium-ion batteries, including advanced electrode material synthesis, power cell design, and assembly for electric vehicles and hybrid electric vehicles, and hydrogen storage using high entropy materials. He authorized more than 60 articles in high impact journals with H-index 13 and 3 patents. He published 6 book chapters also. He received financial support from various international and national funding agencies such as NSF USA, NRB, DRDO, BRNS, DAE, Geetham, and the Crystallographic Society of India. As a visiting researcher, he visited Georgia Institute of Technology, USA, CNRS Laboratories, France, and KMITL University, Thailand. Contributions towards research and teaching recognized as a fellow of the National Academy of Science and recipient of Best Research Award. And also he got Best Teacher Award from academic side. He supervised 15 theses, 15 PhD theses, and 14 project dissertations. He serves on the editorial board of several international journals published by ACS, Wiley, Elsewhere, Springer, Tyler, and Francis. He is a life member of the National Science Congress, the Indian Physics Teachers Association, the Rare Earth Association of India, Society for Materials Chemistry. Today, we are fortunate to have Professor Balaji Rao Ravuri share his insights on the current trends of materials and applications. And also, sir, I thank you for accepting my request, sir. So kindly share my view with us, sir.
సార్ Sir, you are not audible.
Sir, you are not audible. Sir, you are not audible. Sir, you are not audible.
हाँ हाँ. Excuse me, someone please unmute. Okay.
Am I audible to everyone?
Yes, sir.
Yes, sir.
Am I audible?
Yes,
Yes,
sir.
sir.
Am I audible?
Yes,
Yes,
sir.
sir.
Okay, good, good. Something else. Am I audible now?
Yes,
Hello?
sir. Yes, sir.
Yes,
Am
sir.
I- Okay, okay. My first slide is visible to you?
No, sir. Yes, sir. First slide is visible, sir.
First slide is visible.
No,
Okay.
sir. 61, sir. 61 slide.
Oh, that's fine. That's fine. That is the first slide.
Okay, sir.
Okay. We wanted to go for the full slide. One minute.
Admit it. Admit it. Start with that. थोड़ा सा technical problem.
Dear participants, please mute yourself into the entire session.
Am I audible now? Hello.
Yes, sir. You
Sir.
were.
Sorry.
But
When
sir, slide is not in full presentation mode.
no, because the thing is, when I put in slide mode, that means PPT presentation, I am disconnecting from that. That is the problem that I'm facing.
Okay.
Up to this, it is allowing. For example, I go for F5 presenting mode. I am disconnecting from that. That is the problem I'm seeing. I have tried couple of times. What should I do? For example, if I put in the presentation mode, I am disconnecting from this.
మంచిగా చేసుకుంటాను కదా అంతలే ఉంటే మమ్మీ విజయనిత్ గారు మంచిగా ఉంచితే అవలా కాదు నాన్న మంచిగా ఉంటే మమ్మీ తినిద్ది ఎందుకు ఖరాబ్ చేస్తారు అనే గుర్తు వెళ్ళిపోండి
క్రీమ్ బాల
Mr. Nagaraju, please mute yourself.
ఉందిరా దాన్ని అడగ చూడు బూజులు ఎట్టున్నాయి అక్కడ
Sir,
ఆడైంది అది
Mr. Nagaraju, please mute yourself.
Nagaraju, please mute yourself, please. So what should I do? I have a problem here. If I go for the full presentation mode, I am disconnecting from you. That is the reason.
No problem, sir. You can continue like this. We can share. We can see your slide properly. No problem. You can
That is
continue
true,
like this,
but
sir.
no, if the visibility is, we can expect good visibility when we
Yes,
share.
yes.
Let me try once then. Okay, I will continue.
Okay.
Yeah. What is
Dear participant, please wait for some time. Sir is facing some technical problem.
Radhika? Hello.
Sure, hearing, sir. Hearing, sir.
Sir, tell me, sir.
That I have received a phone call from you. That is the reason I am asking.
That it is minimized, then it will open. So that's why I'm trying to use it.
Sir, noise, sir, we are very comfortable with this place. How we can carry on.
Sir, have you tried your logging again? Can you please log in again? Maybe then it will the problem will solve. The error will not come.
Now my presentation is visible. Hello.
Yes, sir. Visible.
Yes, sir. Visible.
Okay.
Visible,
Okay.
sir.
Now full screen. Now full screen.
No, sir.
Full screen is not
No,
visible,
sir.
sir.
But it is
Okay.
But it is comfortable for us, sir.
Oh, then we'll find, because though 1 minute, then we will finish it. No, I should not ask them to wait.
Sir, kindly click the presentation mode down there.
Where it is, then it is the
Down
presentation.
screen.
This Google Meet is new for me because we used to go with Microsoft Teams or Zoom only. Where should I go for the full presentation then? Here?
Sir,
Then,
down
sir,
right.
minimize PPT, sir. Minimize
Ah.
PPT and minimize
Bottom
PPT
right
and
top
the
right.
desktop, sir.
No. I have shared from that place only. There is an arrow mark towards upper direction.
Sir, down right side there is a presentation mode is there. You need to click there. After that, notes is written here. Down right side. Notes.
Down notes, right? Activities
notes,
are there.
Beside that, one present.
1 minute. Tell me. Meeting details is here. Down right.
No, in your screen, sir. In your PPT screen is there. Down right, one notes is here. Okay. Don't click on the notes. Beside that, one book is there. Book-like structure is there.
No. That I know it.
So beside that, presentation mode is there. So presentation mode, if you click that, it will come or not, sir?
No, because I am going with that only. But the problem is when I go with this something, I am missing here. Because if I click here,
to interrupt.
please,
Can you present your entire screen instead of just one window?
So
Present your
minimize
entire
the PPT and Windows, sir.
Instead of just one tab, please present your entire screen, and then the slideshow will be visible.
1 minute then.
At starting, sir.
Okay.
Minimize the total PPT, then you open the entire screen, sir. Then only it opens.
Okay, that is the problem. Thank you.
That's why I'm calling.
1 minute.
Now you minimize the windows. Minimize it and open the your PPT.
Now is open?
Yes, it is open. Yes.
Now in presentation mode?
Yes, sir. Perfect. Sir.
Okay.
Yes.
Okay. Okay, good. I think so. I think everyone should mute now. Right? Okay. So with you people, instead of learning from me, I was learned something about the Google Meet 1 point. Thank you very much for that, for everyone. So am I audible clearly now?
Yes, sir.
Right. Okay.
Yes, sir.
So, thank you for all the management and staff of Malla Reddy group of institutions for inviting me to deliver a talk on the materials for high energy storage. Before we go to the actual talk of the topic about the different materials for hydrogen storage, let me talk about little economics. About economics, once we talk about, there is an important concept given by the government of India under the leadership of Honorable Prime Minister Professor Mr. Narendra Singh Modi ji about Atma Nirbhar Bharat content. In that, we have to build ourselves everything, where this kind of new technologies have come up, new startups have come up. As a result of it, in view of different difficulties with lithium-ion batteries, where the biggest energy storage resource throughout the world, with which we can gain good quantity of money, whatever the money that the India will get, definitely be used for infrastructure development and also to become rich as far as country alone. However, because of expensive element, though it is very much useful, the people are going nowadays towards the sodium-ion battery technology. We have been working on sodium-ion battery technology more than a decade and getting some glimpse about the sodium-ion battery technology from our laboratory, and our students, Ms. Radhika, Sarita, all people have been working along those lines. And with some other group, we have started working on the hydrogen storage as well, with the inspiration of Government of India only. Very recently, if you go through the newspapers, our Government of India wanted to not only initiate to start a public train powered by the hydrogen fuel. Not about a cars, a small domestic appliances. The vision of the Government of India is to power a train with the help of hydrogen as a fuel. Then everyone should think about why and what is the initiative behind it. The initiative behind it is the hydrogen is very economic in nature. Whatever the prices that the trains and the buses nowadays charging, we can reduce, minimize by 10% at least, 20% maximum, so that our common people or poor people can save the money, that the saved money will be useful for their daily needs. In addition to that, the Government of India, if we have storage capabilities, we can transfer the technology to the other countries. As a result, we gain good quantity of amount. This is the main intention behind the materials to be used for the hydrogen storage. In view of that, our group has been successfully started on the hydrogen storage based materials, and then we systematically going towards the storage probabilities. This is what our meant is, hence this topic is intended for. At the end or in between, I don't hesitate to listen any questions from your side. In this hydrogen material storage also, we are under the process, and if anything that we don't know, definitely I will come back with good answers. This is my motive is. Right. Before we talk about the sustainability of the materials and the sustainability of the vehicles run with the help of hydrogen storage, I wanted to, or everyone should know about some fundamentals on hydrogen. And my sincere request to all the participants joined here, I will go one by one because this is a new topic. I will go one by one very slowly so that anything that you wanted to note down, please note down. There is no problem at all. At the end, I will share the PPT to the organizers and you can share it to your friends also. Now, why hydrogen is the concept we are talking about. Now, you see the image, hydrogen storage fuel stations. Nowadays, these stations we have been observing petrol, that means petrol bunks or petrol stations, highways, and small places in hotels and restaurants. Now electrical chargers, that means electrical stations are there to charge our electric vehicles. Now it is being improved. By 2047, in addition to petrol stations, we should see definitely, we and our children will see the hydrogen storage stations where you can fill the hydrogen into your vehicle tanks and then you can go wherever you require. There is no problem at all. The technology is being created. Definitely everyone could enjoy economic way of transport. Now, let me talk about why hydrogen. See that, as I rightly mentioned, these are the advantages. Very importantly, hydrogen is the clean which we require. For example, if you have the clean storage technologies, we can save the health of the people, health and wealth of the people, clean and economic, save health and wealth of the community. Then we can save the money and useful for our personal purpose. And then second one is safest, eco-friendly, as I mentioned, most economical fuel. So there are the four advantages: clean, safest, eco-friendly, and most economical fuel. And up to now, we are addicted to fossil fuels. If you use hydrogen as a fuel for your vehicle, almost zero emissions. Not only the zero emissions, it is recyclable. That is very important. And one more thing, it competes definitely best fuel and integrate to the renewable energy resources. For also to produce, no living things are required. And maximum you can drive up to, with now and then technology that we adapt, 400 to 500 kilometers. That is fine. After 500 kilometers, you go to any station and fill for next 400 to 500 kilometers. This is about 20, if not 2030, I am thinking about 2047 technology. These are the advantages. And then audience definitely ask me, don't we have the difficulties? If all the advantages are there, what is the problem to bring out the new technology into account? Yes, the main disadvantage is volumetric density. You know, all teachers and the research scholars, I feel, as the participants, there are two densities which are very, very important for energy resource or energy technology. One is gravimetric density, that is related to the weight, gravimetric density, gravimetric density. And second one is the volumetric density. You know volume, mass by density. This is about occupation in a tank. I will tell you in the next slide how the volumetric density looks like. Our majority of the people would know about the volumetric density, which is very, very disadvantageous thing, which creates a lot of problem to store the hydrogen in a vehicle. See this right side, visibility, energy consumption worldwide, and it is a forecast until 2050 by energy source. See this. Don't worry about the numbers. You can definitely think about incremental nature from 2000 to 2050. That's why by 2047, obviously you can increase the visibility of this hydrogen storage technology, which will be useful for the common man appliances. Therefore, the projection of the different energies by 2050 is published. It's not my data, it is the BP Energy Outlook data. Right. What is the initiative from our side? The initiative from our side is, 1 minute. To meet the target, our India also have the plans. What is that first plan? National Green Hydrogen Mission. In addition to that, very recently, Honorable Prime Minister launched semiconductor mission also to prepare the chips, indigenous chips. Nowadays, we have been adapting the technologies and importing the chips from the China or Taiwan, etc. But our target and the goal is to prepare our own chips so that our technology would improve. Similarly, another technology the government of India is looking for, National Green Hydrogen Mission, to develop the hydrogen-based storage technology to power the vehicles. Now, there is a target. What is the target of National Green Hydrogen Mission outcomes? As I rightly mentioned, we have to install 6 to 100 gigawatt electrolyzer installations and a good quantity of storage of hydrogen by 2030. Not only that, 125 gigawatt of renewable energy for green hydrogen production. And also not only that, the government has to create good number of jobs in that area. The way now the software companies are creating the job, the green hydrogen mission in the green hydrogen technology also definitely create good number of jobs competent to the software jobs. In addition to that, to improve the good number of jobs into the market, there should be good quantity of investments, almost more than 8 lakhs. This is about the targets of the National Green Hydrogen Mission outcomes. Now, up to these 3 and 4 slides, we had a good interaction about the hydrogen economy, understanding. Secondly, what about our government initiatives to meet the targets? And what are the outcomes? These are the 3 points we have learned. With these important targets, research is to be done in India, is to be initiative, that means research initiatives to be geared up in India. Very few groups in India working on energy storage systems, especially in hydrogen storage. Think, friends, the production of hydrogen is different, storage of hydrogen is different. Now I am talking about hydrogen storage only, with which we are expertise in that. Okay. Production is different. Now come to the main point. As a researcher, everyone must understand what are the advantages of the hydrogen. Just I have mentioned. In addition to that, some points I should mention and you people make a note of it. The first reason is hydrogen is the lightest and most abundant element. Now I have to compare lithium-ion batteries also here. But the difficulty of lithium-ion batteries is also one more. Why lithium-ion batteries are most popular nowadays? In every mobile we have a lithium-ion battery. The reason is lithium is very, very lightest element. So that we can have lightest mobiles or any electronic appliances. But the difficulty with the lithium is abundance. Very rarely abundance is there. In India, very recently, NMDC invented quantity of lithium in Jammu and Kashmir state in a district called Rajouri state. And government is also digging the lithium metal resources to develop our own technology. But the advantage with the hydrogen, lightest and abundant. Because of these reasons, we definitely shift from the lithium-ion battery technology to hydrogen storage technology. And next, one more important point is at normal temperature and pressure, hydrogen is colorless, no doubt, odorless, tasteless. And one more thing which is very, very important is non-toxic in nature, non-metallic in nature. So non-toxicity is the important one more in addition to lithium battery that I am talking about. So when compared with, because when we are talking about the new technology, I should compare with the existing technology. Existing superior technology is lithium-ion battery, where lightest, not abundant. And also the materials which we are using to prepare the lithium-ion battery is toxic in nature. If you go on using the cobalt metal, lithium, cobalt oxide, lithium, other manganese oxide, and recyclability is also a very big problem for the world. We can face the challenge in the form of recyclability also, when we continuously increasing the usage of lithium-ion battery, in addition to unabundance. Therefore, alternative approach towards the most economic process is only the hydrogen. That's why I keep on stressing the advantage of the hydrogen. So, non-toxicity is the major issue, lightest and more abundance. These are the three advantages which give a better solution for the current technologies. That's why we have taken this as a challenge to prepare along those lines. And then most of the hydrogen on Earth in different forms, but in the form of molecular forms such as water or organic compounds. These are the three important glimpses of hydrogen and also physical properties of hydrogen. Density is there, melting point, boiling point, a specific heat. In addition to that, calorific value that I should compare with petrol present trends. So calorific value of the petrol is 46.4 megajoules per kg. Diesel is around 45.6 megajoules per kg, whereas natural gas is 52.2 megajoules per kg. Whereas the calorific value of the hydrogen is triple than the other calorific values of present fuels. These are the 4 advantages of hydrogen made very feasible for the storage technologies. Next, very importantly, the hydrogen and its uses. When you talk about, just I have to give you a glimpse about the hydrogen production. Let us not go into detail with where I am not expertise, but give you 2 important processes: steam and methane reforming reaction. You see, a methane CH4 is reacted with water, CO, that means carbon monoxide will be emitted, with which 3 hydrogens, that means 3 hydrogen H2s will be emitted. That is one process. And the continuation of this reaction, carbon monoxide, again you react with water. What happens? Carbon dioxide will appear. In addition to that, 1 H2 will release. These are the 2 processes which we can produce the hydrogen production very easily. And there are other productions also. Let us think about a similar fashion. Methane added with water, you will get carbon monoxide and 3 H2s. That means 3 H2s will come. Again, carbon monoxide reacts with water. Again, you will get carbon dioxide and the H2. So in addition to that, you will get 4 H2s here, with which we can have a simple hydrogen production in your laboratory. And also, I have to give a small glimpse of information about hydrogen classification based on production. Hydrogen can be produced, as I told you, multiple routes. What is that route? First one is thermochemical process. Just I have mentioned about methane reforming. Similarly, biomass gasification, biomass derived liquid reforming, solar thermochemical hydrogen, and electrolytical process are there. Direct solar water splitting process are there, where photoelectrochemical process, photobiological process. In addition to pure biological process, microbial biomass conversion, photobiological process. Don't worry about all this process. If you want to go with production of hydrogen as a research, you have to choose one among these and then try to do in your laboratory, in your college or in your university, so that slowly you can acquaint with this hydrogen production, so that you will gain the knowledge. Now, 2 parts are over about the hydrogen production as well as the economy of the hydrogen. Friends, now our friends group has prepared the hydrogen which can be used for the transport applications. Now the question comes, how to store the hydrogen? That is the question. For example, in your vehicles, in your cars or two-wheelers, there is a petrol tank where you fill the petrol as a fuel so that you can run the ship. But domestically, now I am connecting hydrogen storage with our butane gas in our home. Every day in our kitchen, we use gas cylinders where butane is the main resource. Almost all people normally think gas, and then it will burn. Flame will come. This is the point. The same technology we adopt here. Interesting thing I will tell you. Hydrogen can be stored physically. Please, everyone must remember. That's why I'm going very slowly. I'm giving you fundamental information about hydrogen storage. Hydrogen can be stored physically in the 2 forms. Number one, in the form of a gas. Remember, friends. Therefore, you can store hydrogen in the form of a gas. Second one, in the form of a liquid. These are the two forms we can store it. Immediately question comes, why not in the form of a solid? That we will come back. One by one, we'll go. Hydrogen can be stored physically in the form of a gas or a liquid. What happens if you store in the form of a gas? What happens if you store in the form of a liquid? I will tell you. Now, storage of hydrogen in the form of a gas, what are the requirements? The requirements are almost we have to prepare the tanks which can withstand, like a petrol tank. We have to design a tank, and the tank can withstand up to 700 bar of pressure. That means if you want to use hydrogen as a fuel, it should require 700 bar pressure. To get 700 bar pressure, the tank should withstand for that much high pressure. Remember, friends, for that we require big tanks. If we require a big tank, it is not to be suited for the transport applications, because always we go with lightweight. Though hydrogen is very, very lightweight, but tanks are very heavy, it could not be used for daily life applications or common life applications. This is the problem with the storage of hydrogen as a gas in tanks. This is very important thing every participant must understand. Okay. Second point is liquid. How to store the hydrogen in the form of liquid. But I out, and everyone thinking about hydrogen is a gas. You know the BSc second year, there is a liquefaction of gas. A principle is given by Kamerlingh-Wonnes, liquefaction of helium, liquefaction of hydrogen. Therefore, if you convert this hydrogen gas in the form of a liquid and also want to store in the form of normal tanks or cylinders, we require very, very ultra low 253 degrees centigrade, friends. Is it possible to maintain such ultra low temperature? Here in India, definitely is not possible. We can maintain very good laboratory, but for difficulties with the storage of hydrogen in the form of a gas, in the form of a liquid. In the form of a gas requires 800 bar tank pressure, which is very difficult. In the form of liquid requires cryogenic temperatures, because for the liquefaction of hydrogen we require the temperature is around minus 253 degrees centigrade. So these two are very difficult process to store the hydrogen. And then third point is hydrogen can be stored via solids. This is the topic that we wanted to discuss. Since the first point and the second point are not feasible, therefore we have to have an alternative technology. What is the technology? Hydrogen can also be stored on the surfaces of the solids. Nowadays, Government of India is also suggesting, as per the NEP, either in engineering colleges or UG colleges, everywhere, we have to include the syllabus of renewable energy storage technologies. There, hydrogen is one unit where we can cover everything. Therefore, this is also very important for all of us, all the teachers, about the fundamental to understand. That's why I'm teaching you No, I'm teaching like a normal students. So hydrogen can also be stored on the surfaces of solids. Now the technology come into the picture. And I think some of the chemistry faculty are also there, and physics students also there, where there are two important topics, adsorption and absorption. Therefore, remember friends, now the technology is hydrogen can be stored on the surface of the solids. That means if you store on the surface of solids, that point is called as adsorption. If you store the hydrogen within the layers of the solid, that is called as absorption. There are two phenomena, friends. Number one is adsorption, number two is absorption. That means if you store the hydrogen on the surface of solids, that means you store the hydrogen with the help of adsorption phenomena. If you lock the hydrogen atoms inside the material, that is what is called the storage of hydrogen via absorption. Now I will explain you. Sir, with the help of adsorption, if the hydrogen atoms are stored on the surface, if you give a little pressure or force on to the surface of the material, the hydrogens will come out and then can be used as the fuel. And one more thing, with the help of absorption, what do you mean by absorption? Absorption is the location of the hydrogen inside the material. I will show you the pictures inside the material. You have to apply little extra pressure than the adsorption so that the hydrogens will come out of the different layers of the material and can be used as the fuel. These are the two technologies. So with this third point and very oldest chemical technique, that is adsorption and absorption phenomena, can be used for the storage of hydrogen on the surface of solids and within the solids. Right. Now I think all the points I have covered. Right. Now, second thing is, there are two ways of storing the hydrogen. Again, what kind of methods? Just I have mentioned about material based. What do you mean by material based? Material based means take a material, whether it is an inorganic material, organic material, where hydrogen atoms are to be placed at their substitutional positions or interstitial positions and at different places where defects of the solids comes into picture. When you apply a small pressure on it, from the interstitial positions and substitutional positions, the hydrogen will come out and can be used as a fuel. This is the technology, material based. And physical based, already I told you. What is that physical based? We have to use the gas tanks, liquefaction, etc., etc. So hence the hydrogen storage can be converted into two methods, physical method and material based method. But physical method is very, very difficult. Therefore, it is not feasible. But the feasible process is material based storage, hydrogen technologies, where we are right now. Now, as I rightly mentioned, the first point is adsorbent. What do you mean by absorption? Storage of hydrogen inside the layers of the material or a solid. And one more thing, take an organic compound. In the organic compound, the H2, that means hydrogen atoms, are linked there inside. Give you a little pressure so that hydrogen atoms will come out from the organic compound, liquid compound. And as I already mentioned, interstitial hydride, and then complex hydride, and a chemical hydrogen. as I rightly mentioned, interstitial positions in the interest because of the defects of the solids. That means that you have been teaching to your students. Wherever you see the interstitial positions because of defects, you insert the hydrogen into the places and apply a little pressure such that the hydrogen will come out of it. So the complex hydride also like that, and the chemical hydrogen is also one kind of process. So with this, we can understand gas and liquid storage is not feasible. They are called as physical based storage of hydrogen. And the alternative approach is the material based compound, where with the help of adsorption and absorption, take the different compounds like metal hydrates and other compound organic compounds, where you store the hydrogen atoms either at the interstitial positions or as a links or as a chemical bond, and by pressing or the giving force or pressure, the hydrogens will come out of that material and can be used as a fuel. This is the broad perspective of the hydrogen storage technologies. And friends, still if you want to find out any clarity information, and you can go to browse to the Google or the YouTube, and also some more information you gather and get good quantity of the knowledge than I teach here. Now, second point about the hydrogen, compressor hydrogen, high pressure hydrogen tanks. Here, there is a kind of steps, V1 step, V2 step, V3 step, and V4 step, etc., etc., which I don't want to discuss about. Why? Because I'm not interested in physical based storage of hydrogen. But this is a process, that's why I wanted to give you. So V1 is the all metal, V2 is the metal liner plus some layer, and a metal liner for one more layer, metal layer for another more layer. So if we want to see the hydrogen tanks, there are the different layers, V1, V2, V3, V4, where different layers will be there to store the hydrogen and to withstand the pressure of 800 bars. Since 1918 onwards, the process is going on, but successful, but not being properly used. Into that, I wanted to give a small glimpse on liquid hydrogen carriers. Remember, friends, this is a liquid hydrogen tank like our gas cylinder inside, but there are 13 layers. You can easily understand. You people are teaching a topic called optical fiber, core and cladding, outer jacket, this and that. There are different layers with which we can minimize the moisture and also protect during pulling and pushing. Similarly, to store the hydrogen in the hydrogen tanks in the form of a liquid, not in the form of a gas, there are 13 layers are required. Outer tank, inner tank, coupling, heater, heat exchanger, shut-off valve, boil valve, support loss, liquid level sensor. There are different layers. That means this is a very, very tedious process. Therefore, friends, for your glimpse, I am giving you the difficulties in understanding the gas storage and liquid storage of hydrogen in the form of storage. I have to give you a glimpse, that's why I have given you. Now, come to the, again, our interesting point that I have taught you one slide before about the material-based hydrogen storage. Now, I am talking about one difficulty, one disadvantage in the first slide, if you remember, volumetric density. But if you store the hydrogen in the form of a solid materials, that volumetric disadvantage will be resolved. See, friends, to drive your vehicle for 400 kilometers range using a hydrogen fuel cell, How many kgs of hydrogen required? Remember, friends, 4 kgs of hydrogen required. Therefore, for 100 kilometers, 1 kg. So now you can free, friends. 1 liter of petrol nowadays for the two-wheelers is around 50 kilometers, or big vehicles 30 to 40. For our cars, almost in between 20-25. But here, if you fill 1 kg of hydrogen, obviously you can drive 100 kilometers. That is the advantage. But if you see the similar way, hydrogen gas 128 liter is required. Liquid 59 liter is required, in addition to the pressure and the temperature. As I keep on mentioning that. The reason also I will show you in the bottom images. See, friends, take in the form of gas, He2 gas, room temperature, that means room temperature in atmosphere. What is the mean distance between hydrogen molecules? 3.3 nanometers. Whereas the same hydrogen gas at higher pressures is around 350 atmospheres at room temperature, 0.54 nanometers between the hydrogen molecules. Mean distance on an average. If you think about liquid hydrogen, 1 atmosphere, that too at low temperature, minus 253 degrees centigrade. See the average distance between the molecules, 0.36 nanometers. That I understand. That means gas is better than liquid, that we are understanding. Whereas in the case of storage of hydrogen in the metal hydrides. Now, friends, I am talking about metal hydride. For example, you take magnesium hydride, Mg. Hydride means He2. Metal, magnesium hydride. And you will also ask me one question, sir, why firstly you told about magnesium? Magnesium is also lightest element. That's why I am going here with lightest element. Hydride H2. MgH2 is called as magnesium hydride. And here I will tell you, these are the bigger circles. You know about lattice crystal? Bigger circles. You think about magnesium, positions of the magnesium atoms. What is this order? They have the long range order, friends. It has a long range order. For example, in this long range order, 1, 2, 3, 4 atoms are there. Among these 4 atoms, there is a blue color where you can see the hydrogen atoms. This position is an interstitial position. Therefore, you store the hydrogen atoms in between the 4 hydrogen atoms. If you give a little pressure, so that hydrogen atoms will come out in 3 dimensions, so that you can use that hydrogen as a fuel for other purposes. Now, my point is about the high range order. I'm talking about the crystalline metal hydrides. Why I stress here, I will be talking about amorphous, partially crystallized material also at the end of my talk, where we are concentrating much on it. So, in these cases, the mean distance between the hydrogen atoms in the case of solid state hydrogen storage, less than liquefaction, 0.21 nanometers, and it is freely useful. That means no ultra low temperatures, no high pressures are required. I'm talking about just room temperature process. There should not be any difficulty. Therefore, the metal hydrides nowadays plays very vital role in storing the hydrogen for vehicle or transport application. So I am very slowly one by one. Gas, liquid, and storage of hydrogen in the material. That means solid state storage. Possibly everyone is following my talk. Now, again, one more time, I'm stressing on very important points as a table. If I give you table about the glimpse, definitely everyone can attract this table. Take the picture of it so that it is very easy. As I rightly mentioning, go on, storage method is gas, material used high pressure tanks, because everything I take in one picture, but only the pressure, only the picture. Take the pressure, how many? 800 atmospheres. What is the phenomena? Compressor gas, molecular hydrogen. But what is the problem? I am giving you the problem here as a remark. 800 atmosphere pressure is a safety concern. Possibility of explosion. We don't need this. Liquid, cryogenic tanks vary with size, but temperature maintain ultra low temperatures. This is the problem. Solid. Now come to the point again. What are the difficulties that I wanted to talk? With the help of, see friends, carbon nanotubes. What is the carbon nanotube you people are teaching for your students, engineering student? What is the advantage of carbon nanotube? It has high surface area to volume ratio. Therefore, we talk about high surface area material. If you talk about the carbon nanotube material, we need the temperature almost around 100 and minus 196 degrees. That means this possibility is also seized, though it is an absorption, because low operating temperature is not feasible for us. And one more compound, very recently you have been listening, intermetallic compound. What is this? Intermetallic compound. You browse in the Google, you will definitely find it. That means lanthanum nickel combination, like an alloy. Remember friends, alloy. What is this alloy compound? One lanthanum element should connect with 5 nickel elements, 5 nickel atoms. So anyway, alloy means what? Combination of the 2 elements. That's why we are calling it as intermetallic compounds. Though 2 things are okay, but it is very having weight percentage very less. But this is phenomena is absorption phenomena, and low capacity is the problem. I don't think so there is a safety problem, but though safety problem is there, but low capacity we don't require. And then magnesium elements, I already mentioned right now, lowest element. Though you use only magnesium element, there are problems related to 340 degrees centigrade high temperature. Remember friends, for above low temperatures you require, but in the case of magnesium elements, high temperature is required. But the process is absorption, but high capacity, high temperature absorption. Now friends, everyone has a better understanding on the storage of hydrogen via different phenomena. What are the advantages and problems related to different things, gas, liquid and solid. Therefore, I wanted to have a table of it and keep in front of you so that you would have an idea how to go about. Now, I don't want to go into thermodynamical parameters. This is not the time. I wanted to give a glimpse of it because I have to reduce the temperature from T3 to T1, from maximum temperature to minimum temperature, and then pressure also. For this reason, I want, but I don't want to give you Gibbs phase rule about everything. Now, just I have already mentioned metal hydrogen system. What are the targets for metal hydrogen storage means? It is not the targets I have given. Department of Energy, US has given. What are the kinetics? Number one is about the temperature. That means you can minimize up to 85 degrees centigrade in vehicles. And the storage capacity is around 5.58%. And how many cycles you require? Here I am giving you greater than 1000 cycles, but I can go 1000 cycles to 1500 cycles, 500 to 1500 cycles, that is fine for now. And how much pressure is required? 5 to 12 bars. So these are the 4 important parameters that we have to take care about. Temperature, storage capability, pressure, and then cyclability, kinetics. Our senior researchers have been working along those lines. Now, see friends, metal alloy I am talking about the hydride. Now you understand clearly how the connection between a metal and hydride. What is this metal? Palladium. Connect with hydride. But the temperature requires 125. Pressure is okay. But maintaining 125 temperature is not the target of the Department of Energy, US. 85 degrees is the temperature. So take magnesium hydride. No. Titanium hydride. No. Vanadium hydride doesn't work. Temperature is okay. Pressure is a little higher. Lanthanum, okay. Magnesium dihydride, nickel, Mg2Ni, but the temperature is also high. Iron titanium, and also temperature is high, 5 pressure. That means when compared with all these things, you think iron titanate. That means iron, maximum of iron titanate, titanium hydride. That means combination of iron titanium, any mixture. Therefore, you can talk like 2 elements are combining. Therefore, alloy added with the tag with hydride, then having good results. Therefore, the scientists have come to an idea. We have to have connection of hydride H2 with alloys. Alloy is having the 2 elements, so that we can operate at room temperature, and also pressure is okay, but 5 pressure. No, I don't want to go to the 5 atmospheres. I want to come for 1 atmosphere pressure, where the research.
Dear participants, please wait for some time. I think there is some network issue in Sir's side. So we will wait for some time.
Sir, audio not visible.
There is some network issue from sir's side. Please wait for some time, dear participants.
డిస్కనెక్ట్ అయినట్టు తెలియదు. మేడంకి ఒకసారి అనౌన్స్ చేయండి, 2 minutes మళ్ళీ రెజ్యూమ్.
Dear participants, there is some technical issue. Sir will rejoin within 2 minutes. Please wait for some time.
Now okay from my side?
Yes, sir.
Yes, sir. Yes, sir. Okay.
I'm sorry, I did not know that I would disconnect.
Coming, sir.
Did I disconnect? This slide I have taught you?
Which slide?
This slide I have taught you?
Yes, sir.
Okay, this I did not?
This one
Before, sir. Before, sir.
This also done?
The sheet is running, sir.
This is running? Okay, right. I'm
ending
sorry for
position.
that. I'm sorry for that. Right. So, no, because I did not know that, so otherwise I could have been informed you people. Right.
Okay.
So with this one, I wanted to convey to everyone that for the first 4 points, they go with, researchers went with single metals connected with hydrides, but there are different issues related to the pressure and temperature. Hence, people stopped working along those lines. Again, people started working with alloys. These are the 4 alloys. That means lanthanum mixed with nickel and connected with hydrogen. LaNi5H6. This is an alloy mixed with hydride. Therefore, temperature is room, but okay. But lanthanum is very expensive metal. And then connect with magnesium nickel mixed with hydrogen, but temperature is very high. And also iron titanium. In the case of iron titanium mixed with hydrogen, that means interact with hydrogen, the pressure is a little higher, room temperature is okay. Now, with this, I can definitely tell you a common conclusion for all the audience, supporters here, the participants here. An alloy is giving reasonably good results related to the main physical parameters. That means the thermal parameters like the temperature at the room temperature, pressure at 5. Now, what is the content? We have to reduce the pressure from 5 atmospheres to 1 atmosphere. And the temperature also we can reduce little. which motivates us towards a new material synthesis and testing. Remember, friends, chemistry people are and physics people also here. Mixing of the two metals, iron plus titanium, whatever may be the percentage. This could be an alloy. But related to the two alloys, iron, titanium, this could be a low entropy. But in the earlier slide, I am talking about metal hydride. This side metal hydride. This metal hydride is an ordered compound, a crystalline compound, where the hydrogens store in the interstitial positions. But it requires little pressure also. But if you increase the entropy from minimum to medium, medium to high, definitely there will be a kind of breakthrough research to reduce the pressure to normal and temperature also to normal temperature. And volumetric aspects also can be optimized. As a result, we can have viable technology. This is what is the objective. So this Li part motivates us towards the working of hydrogen storage related to the entropy. Right. This slide gives very beautiful information related to storage of hydrogen with two compounds. Just I have shown you here: physiosorption, chemisorption, metal hydrosolid solution, metal hydride. I will give you with important point. See the top picture. I told you what do you mean by adsorption. Adsorption is nothing but accumulation of hydrogens on the surface. And also absorption. Absorption, accumulation of hydrogens inside the metal. See this. Metal hydride. There are different atoms present here. In between different colors, hydrogens are there. Give a little pressure, hydrogen will come out. Now I want to talk about physiosorption and chemisorption. Remember, these two topics are related to adsorption phenomena on the surface compound, not inside the compound, in the layers of the compound. But if you see beautifully, in the case of chemisorption, there are active centers. Please see the friends images. What is this called? Active center. What is the role of active center here? The active center gives a suitable space to sit hydrogens at its places. Suitable centers. Suitable places perfectly. That is the advantage of the chemisorption than the physiosorption. Physiosorption is the phenomena or a surface phenomena where hydrogen atoms just present on its surface. But with the help of a chemisorption, we can create the good number of active centers where we need to give a proper active centers to sit on their own places of hydrogen, which gives more convenient to release the hydrogens from that material and then can be used as a fuel. So everyone has its own advantages and disadvantages, but I like the chemisorption than physiosorption. If you go through these 4 important points, here in the case of physiosorption, hydrogen is adsorption at the surface by van der Waals interactions. Remember friends, what is that? Van der Waals interaction. That means there is a weak chemical forces on the surface of the material where hydrogen will be adsorbed. Now everyone understand what about the adsorption. In the case of chemisorption, H2 is chemically held. That means H2 is chemically held, is a linkages into reaction sites with the help of a chemical bonding. That is what I wanted to call as an active sites. Am I audible to everyone? Again, I have disconnected. Hello?
No, sir.
Yeah, right.
Yes, sir.
Okay. So, in the case of physisorption and chemisorption, van der Waals interactions, locking of the hydrogens with the help of a chemical bonds. And one more important, physisorption work at normal temperatures or at high pressures. But this chemisorption takes place at little higher temperatures. Advantages and disadvantages. No activation energy is required, but here activation energy is required. But the advantage with the physisorption is hydrogen can be stored in multi-layers, whereas the chemisorption stored in only monolayer. And by now, all the participants have understood why only monolayer in case of chemisorption. On the surface of the material, we can create one layer of active centers only. If you create only one layer of active centers where hydrogens can sit. But understand, friends, one more challenge that I give it to everyone, each and every participant, if the same surface of the material, if you can able to create, whether it is an organic compound or an organic compound, don't worry about it. Different multi-layers of active centers, different multi-layers of active centers in three-dimensional way, that could be solved the problem which we are talking about. See, friends, for chemistry faculty or engineering faculty or physics faculty, one more challenge that I throw to the audience, with the help of a chemisorption, if you prepare a material which can create the active centers at the different layers, then you can minimize the defects in the chemisorption and we can use it for the hydrogen storage with the help of a chemisorption. That is what is called in the part of adsorption. Because in the adsorption, there are two methods, physisorption and chemisorption. So I am teaching you like the school children, please. And chemical hydride storage. That is storage of the materials in the petrol pumps. That means the hydrogen pumps. How? With the help of calcium hydride, lithium aluminum hydride, magnesium hydrides mixed with water. Therefore, what happens? NaBO2 will form and 4 H2s will generate. In addition to that, a small heat will be generated. No issue. So, rapid and controlled hydrogen generation, storage and transportation will be occurred. However, as I rightly mentioned, the spent fuel can be recycled and recharged. Therefore, hydrate generation reaction is little expensive, but you can make it inexpensive by doing some extra research work with the help of a chemical hydrate storage technology. There are the two challenges. Number one, with the help of adsorption technique, prepare a material where you can have multiple active layers of the sites. That is one option. And one more option here, reduce hydrate generation reaction to reduce it to inexpensive. We have to have additional steps with the organic reaction people are using nowadays with the metal organic frameworks, MOFs and COFs also, chemical bonding frameworks also. Do that kind of research also, you could get some kind of good results where you can publish good number of publications with good impact factor. That is also a possible option. This is the thing that I have been talking about. Metal hydride, half hydrogen, you will give you solid hydride or finally composed by solid particles with high surface area. This is about metal hydride storage. This metal hydro storage, I told you, this is a absorption technique. Just I have told you. Absorption technique is storage of the H2s in the materials. Now, that part is also over. Organizers, how much I have time left over? Because the participants may get bored or something. Meanwhile, I have to. Hello? Hello? Am I audible? Yes. Can I continue for about only 10 minutes? That is fine?
Yes, sir.
Okay, right. Otherwise, participants long on because they feel little. Okay.
You can make
Yeah. Right, sir. So now, in the earlier table, I'm going back. Earlier table, I have mentioned about individual metals and the alloys, metal alloys. So from low to medium entropy, ordered compounds. Now I must talk about disordered compounds. Those alloys are called as high entropy alloys. Now, friends, in the first image, bottom first image, all the H2s are at the surface. So that is a adsorption phenomena, you can think. Is a solid solution. Solid solution is also called as a adsorption phenomena. That means solid solution is targeting hydrogens at the surface, but very, very low places. That means minimal concentration of H2s will appear here and there in the compound at the center. But in the case of hydride, if you see, all the atoms are orderly arranged at different places where interstitial positions are there. With these three images, obviously you can understand. Now, see the alloy. What is the motivation? With the help of alloy, we are getting room temperature and pressure storage. Therefore, in the first Li, conventional Li you see with medium entropy or low entropy, all are black color elements. That means 90% of iron, and yellow color 5% of titanium, and one more colors is there. This color, these three colors may be hydrides. That means H2s. That means, as I rightly mentioned, iron, titanium, H2. That means majority of the iron, medium is hydride, titanium, low concentration is hydride. But with this, the main problem with the low entropy. Now go to this very important compound. There different colors are there. I will show you in the next slide. Different colors are there. How a high entropy alloy can be formed? That is the question. Why? Because when compared with the medium entropy, low entropy, high entropy compounds can store large quantity of the hydrogen, which can be used for solid state applications. Magnesium hydrogen storage I have given you. You can see how hydrogens can connect with one magnesium in this image, MgHH, so that you can give a pressure from which the hydrogen will come out. And before I go to the actual high entropy alloy, I wanted to talk about a real application. See from this friend, a material solid material network. This is called as industrial scale electrolyzer with 100 kg of solid state hydrogen storage unit. Energy content is in the order of 3.3 megawatt hour. What is this? Magnesium hydride as a hydrogen source When was developed? 2013. That means 10 years ago. What are the advantages with this electrolyzer? Reversible hydrogen storage, high cycling capacity, energy cost maintenance reasonably good, significant reduction in safety risk when compared with present technologies. So this is the real content. With the help of magnesium hydride was designed, called as industrial scale electrolyzer in 2013. So there is a possibility for realizing the technology. I don't want to discuss about conventional alloy, high entropy alloy, because I already told you conventional alloy contains two base elements. High entropy alloy should have minimum 5 principal elements. In the earlier, I have discussed about iron, titanium, connect with H2. But in the case of high entropy alloy, we have to connect with 5 elements. I will show you in the next slide. As I mentioned, on high entropy materials, research started in the year 2004 with a scientist called as Cantor, slowly going on and developing for different applications. Now the question comes, you are talking about low entropy, medium entropy, high entropy. When do you call the alloy, high entropy alloy having high entropy? Do we have any number with which we can call it as either low entropy or high entropy and medium entropy? Yes, we have a number. What is this formula? Because there is a deep study, I don't want to go into details. I will talk about a simple content, equifraction. This is a formula, delta S configuration, configurational entropy. What is the formula? R, gas constant, ln of n. What is n? N is equal to number of elements. For example, if 5 elements are there, capital R, ln of 5, you can calculate. That means there is a range. What is that range? I will give you here. Low entropy, medium entropy. See friends, I am giving you in the table, capital N refers number of elements. For example, one element is not at an Li, no entropy. That means you talk about only iron, only one element is there, configurational entropy is 0. Now, talk about 2 elements. What about that? Iron and titanium, right? Which we have discussed. 2 elements are there. Capital R into ln of 2. Calculate it, how much it is? 0.69 capital R. Go with 3 elements. What is the configuration? Entropy 1.1 R. Go with 4, 1.39 R. Go with 5, 1.61 R. Where I stop. Remember friends, below 1 to 1.5, that means range, I will give you here. Less than 1 capital R, less than R. If delta S configurational value is less than R, that is called as a low entropy compounds. Therefore, if only 2 elements are there, or only 1 element is there, that can be called as low entropy compound. In between 1 to 1.5, that means 3 and 4. Example I give you, iron, titanium, nickel and magnesium. For example, I am giving, it is not correct, but I am giving example. Iron, titanium, magnesium and nickel, which we have discussed earlier. That means 4 elements mixed together. Then if 4 elements is, what is the maximum? 1.39 R only. Still they are called as medium entropy elements, medium entropy alloys. Therefore, in between 1 to 1.5, less than 1.5. So in between 1 to 1.5, that is called as a medium entropy alloy. Greater than 1.5, that means capital R of ln of n. N is equal to 5. You can have 1.61 capital R. That means if you claim that the alloy belong to high entropy, you must have minimum of 5 principal elements. I can give you 5 principal elements. In this, A is iron, B is titanium, C is magnesium, D is equal to nickel, E is equal to manganese. That means A figure does not give any configurational entropy. Why? The reason is it is having the orderness. AA, similar elements. AA, similar elements. AA, similar elements. BB, similar. That means all the similar elements are arranged in an orderly manner. The way we normally in this school stand for national anthem or morning assembly. If all the elements stand like an assembly in an order A, B, C, D, E, that is not at all an order, it is having a full order. If it is a full order, you can claim it as an entropy, low entropy. Therefore, it is not at all a configurational entropy. So in the B picture, if you read the bottom, mixing to form a random solid solution. That means all the elements are randomly mixed together. As a result, A, B, C, D, E elements join together on their own. We cannot predict. That means we cannot predict how A connect with B, B connect with C, C connect with D, D connect with E. So that there is a disorder in its arrangement. Because of this disorder, that means entropy will increase. That is what is called degree of entropy, degree of disorderness. So if 5 elements are there, degree of configurational entropy would increase, which is equivalent to 1.6 R. This is what my point is. So minimum is equal to 5 principal elements. And from the audience, I can get a question. Sir, you are talking about minimum of 5 elements with 1.61 R as the configurational entropy. How many maximum elements can put? But theoretically, I can say up to 13 elements. But researchers had to work on these many elements that we need to discuss about. But up to now, we are going 5, 6, 7, and 8. We have not gone to 9 to 13. Because days to go, definitely we should discuss about those consequences. By now, I think everyone understood about the configurational entropy. I come to one, this is the image that which I have discussed already. This also I have discussed. Right. What are the 4 advantages of the high entropy? If you prepare a high entropy material with greater than 1.5 R, that means 1.6 R, what are the 4 effects will come into picture? 4 properties will come into picture. When you are teaching to your students about the 4 properties of the laser, like unidirectionality, high coherence, high intensity, high directionality, because of those 4 reasons, 4 properties, laser is very, very important in any daily life application. Similarly, high entropy has 4 important properties. Because of this high entropy material alloys are widely used in medical application, medical equipment applications, aerospace applications, military applications, defense applications, and storage applications. Where not? Everywhere, for different varieties of applications, it is started. Therefore, from 2000 onwards, people are vigorously working. What are these properties means? High entropy effect. That is the thing that we have discussed. Because of the high entropy, what will happen? Lattice severely disturbed. Lattice severely distorted. That effect is called as severe lattice distortion effect. In view of that, there is a diffusion comes into picture. Diffusion means who will diffuse? Hydrogen. That means H2s will diffuse into the compound in the form of absorption. That is what is called sluggish diffusion. And different elements present here. That is what is called mixing of different atomic sizes, elements mixed together. There is an effect. That effect is called as a cocktail effect. Because of the cocktail effect is also storage mechanism would improve. So to give the details of each and every content, it requires a lot of time, but I don't want to give it. But take this information into account and browse in YouTube or Google. Definitely you will get good information about cocktail effect, sluggish diffusion, lattice distortion effect, high entropy effect as well. However, I will give you this content and you can go through it. I have been giving in this one more slide with an example so that you can have an idea about it, cocktail effect and everything. And one more important thing. So cocktail effect details was given by one of our Indian scientists, Professor Ranganathan. So with this, cocktail effect is more popularized for the storage applications as well. But if I want to give you one glimpse about the cocktail effect, for example, you talk about the aluminum content. If the content quantity, atomic percent is less than 15, only FCC phase, greater than 35, it is only BCC phase. But we need mixer phases, both FCC and BCC phase. Therefore, the composition must be in the order of in between 15 to 35. That is a recommendable major principal element. But you can add here and there small compounds of the dopants as well. Now the research groups are working along the content doping also along those lines to see good properties. This is about the cocktail effect, right? So, and there are now and then scientists are calculating so many parameters. In addition to, as I mentioned, sir, only high entropy with the help of delta S configuration is equal to capital R into N. No other parameters are required? Yes. There are different parameters. Scientists have been working on different high entropy materials with different formulae. Theoretical scientists are also working. Then if it is a high entropy alloy, what could be the melting temperature? How to calculate the melting temperature of the high entropy alloy? And also some sigma parameter, that is what is called a physical parameter. And also about the phase details you have to give, and about the total electronegativity, electropositivity, susceptibility, electronegativity, and some physical parameters, melting temperatures. There are different parameters in addition to the entropy comes into picture to decide whether the given compound is designed for a particular application having high entropy or not. So, and still scientists are working on improving the good number of properties to look into the different varieties of high entropy concept. So before I complete my presentation, one more, before the participants ask me a question, I have to give you one important. Sir, here in this, right, here in this, there are 5 elements. There are 5 elements: aluminum, cobalt, chromium, iron, nickel. I am explaining a beautiful naming of high entropy alloy. Naming. How do we name it? Because different elements are there is a nomenclature to be followed. If aluminum, cobalt, chromium, iron, nickel is there, I'm giving a simple example. Why don't I give you nickel as a first number, first element, aluminum as a last number? That means, can't I call it as a nickel 1.1, cobalt 2.2, chromium 1.1, aluminum 3.3 like that? Why I name it like this? That means to name any high entropy alloy, you must follow an alphabetical order. That is the standard procedure protocol given by the scientists. What is this? We have to go by alphabets. So what are the elements present here? Aluminum, cobalt, chromium, iron, nickel. These are the elements present here. So search the alpha. First aluminum comes into picture, right? Aluminum. What is the content that you have put? 33.3 atomic percentage. Second one alphabet, what is not chromium, iron, nickel? C, A, B, C. So after O, R will come. Therefore, I put cobalt, 22.2. Right. After that, this C again come. O after that, R come. That means chromium, 11.1. And then iron comes. And then nickel comes. So this is the way naming of hydrogen, high entropy alloys also plays a critical role and follow a protocol to work along those lines. So friends, summarize total. I have discussed about the use of hydrogen economy or hydrogen power storage vehicles, and secondly about different storage technologies, gas, liquid and solid type of technologies, physical storage and material based storage, and then how the physical storage is not feasible, only material storage is feasible, and how the adsorption and absorption will come into picture, and the disadvantages, and absorption comes into picture, metals and metal alloys comes into low entropy, medium entropy and high entropy, and how high entropy concept can be derived, delta configurational entropy, and then calculation of entropy value, and naming of high entropy, use of high entropy properties for storage technologies. Four properties I have explained. With this, all the things I have covered, but sometime real storage with high entropy that I will talk about in the next talk, right? Thank you very much for giving me this opportunity for about patient listening of 2 hours by audience across the India. Thank you very much. And I should thank my group for their efforts in different areas of research in storage as well as storage, means hydrogen storage and normal lithium ion batteries. Because of this group only I am here. Otherwise, I will be zero, no doubt about it. My students is my strength. Thank you very much for your patient listening. Now, the floor is yours, organizers, for question and answers, if anything.
Thank you so much, sir. That was a wonderful session. We all are enriched with your very informative presentation. So now we have some time for Q&A session. I'm requested all the participants to ask any question directly to sir, or you can also use the chat feature. We will address your questions.
And also can write, if any difficulty is there, can write to my email. Anywhere, email. Please share my email in the chat box. That also
Yes,
can be no issue about.
Sure, sir.
Yes.
Sir, excuse me, sir.
Yeah, Radhika.
Sir is asking for one question.
Yeah.
Hello, sir.
Yeah, please.
Good afternoon, sir.
Good afternoon.
I'm Dr. Prakash, sir.
Wonderful.
I have some doubts, sir.
Yeah, please.
Batteries, hydrogen battery you are preparing. So it is very nice, and it is work also very nice, sir. How to environmentally friend and how to correlate with the entropy system, sir?
Okay. The thing is, let us confine with the 2 parameters, right?
Okay, sir.
What is that? One is pressure, and second one is temperature.
Yes, sir.
For the safest fuel, always we thought about normal temperature and pressures.
Yes, sir.
But with the help of low entropy alloys, The problem is little higher pressures required, and sometimes higher temperatures also required. But as far as the Department of Energy US concerned, 85 degrees is the maximum. You should not go
ஸ்டாக்
below.
வெரிஃபிகேஷன் வந்தாப்புல
Yes, sir.
என்சிடி
Yes, sir.
இருக்குமே எனக்கு ஸ்டாஃப் வந்தான் டேய் எம்மி பண்ணிட்டியா எம்மி எல்லாம் இல்லைங்க பி தாங்க எம்மி
Mr.
பண்ணிடுறேன் நம்ம
Srinivasan,
ஃப்ரீயா தான் இருக்குது
Mr. Srinivasan, please mute yourself.
Right. Now, if you see, this is an ordered compound.
Okay.
In this ordered compound, all the H2s normally store at the interstitial.
நீ கொண்டு மறுபடியும் எங்க போறேன் இன்ஜினியரிங் காலேஜ் போவியா இந்த ஃபீல்டே வேணாங்கிற மைண்ட் செட்டுக்கு வந்தாச்சு
So exactly stores at a particular places, right?
Yes, sir. Yes, sir. Yes, sir.
At a particular places.
வேணா
If you give a uniform pressure along x-axis, y-axis or z-axis, obviously the hydrogens will come out. In the case of metal hydrates, right?
Yes,
In the case of low entropy compounds.
அதுக்காக இப்ப
For
போட்டாங்க
example, if you
ரெண்டாவது
see high entropy compounds,
நம்பருக்கு நிம்மதியா இருக்கலாம்
if you see in the case of high entropy compounds,
Sir, sorry to interrupt you, sir.
please.
Mr. Srinivasan, please mute yourself.
Right. If you see in the high entropy, if you see in the high entropy
சதீஷன்
compound,
சொன்னாப்பா
A, B, C, D, E.
Yes, sir.
In the case of A, B, C, D, E, A might have different size and electronegativity, and that means different elements are having different sizes and different physical properties. Therefore, you can find a good number of interstitial positions than the ordered compound. If a good number of interstitial positions are there, only because of the high entropy. If good number of interstitial positions are there, obviously the storage places for H2 to keep at interstitial positions will be more. As a result, that means the power density, energy density will be more. With this help of high entropy, obviously we could improve the energy density as well as the power density. That is the concept of the high entropy.
Saumita madam.
Any other question from participants? Raise your hand, please, or you can post your question in chat box.
Sir, thank you for your giving that feedback, sir. That the question answer is very wonderful, sir. What is the electrolyte you are using, sir? Without electrolyte or with the metal only, sir?
No. Okay, this question is in this case of hydrogen storage, there is no such kind of cathode, anode, electrode kind of thing. If it is a lithium-ion battery, we have or any kind of battery, we have cathode, anode, and electrolyte, right?
Yes, sir.
For this question also, I will try to explain you at the end. No issue, because because I have okay. Let me finish. I will show you one video for this. So everyone can see this image. Okay, please enjoy this video so that about cathodes, anodes, and electrolyte we'll see. I don't want to explain, but see it.
Okay.
Read it also, aluminum and copper. So aluminum is cathode, copper is anode. Yellow and white. There is a layer, transparent layer, is a separator. So this is the microstructure of the compound. Okay, bottom microseparator compounds. There is a transparent sheet that is what is called an electrolyte separator. Now ions are coming during discharging and charging. See, enjoy this video. You think this is cathode from anode during charging, discharging from anode to cathode.
Right, sir.
Once the charging is completed, now how on the material surface it places that different places in a random manner, nothing but entropy, high entropy. It's not in a proper place.
Thank you, sir.
Now,
Wonderful.
now
Very, very wonderful work, sir.
it is
Thank you.
during
Thank you.
discharging is also
Yeah,
you can see
my
it.
pleasure, sir. Thank you.
Right. Okay.
Thank you very much, sir, for your enlightening presentation. Now, formally express our gratitude and acknowledge everyone who made this faculty development program possible. I would like to invite our fellow colleague, Sir M. Srikant, to deliver the vote of thanks. Over to you, Srikant, sir.
Thank you very much, Dr. Samita Jana Madam, for giving me the opportunity to say a vote of thanks. Distinguished guests, as we come to the close of this enlightening faculty development program on current trends in materials and their applications, it is my privilege to extend a heartfelt vote of thanks to everyone who made this event a success. First and foremost, I would like to express our deepest gratitude to Professor Balaji Rao Rauri for sharing his extensive knowledge and valuable insights with us today. Your presentation has been truly inspiring and has provided us with a deeper understanding of the latest developments in material science. Thank you for your time and for being a part of this program, sir. I would also like to thank our principal, sir, Dr. M. Ashok Garu, and our beloved head of the department, Madam Dr. Sneha Joshi, Madam, for their continuous support and encouragement. Your guidance has been instrumental in organizing this event and for fostering an environment of academic excellence. A special thanks to the organizing committee and all the staff members whose hard work and dedication have made this program possible. Your efforts behind the scenes have ensured that everything ran smoothly. I am also grateful to all the participants for your active engagement and enthusiasm throughout the session. Your presence and participation have greatly enriched the discussions and made this event truly interactive and beneficial. Lastly, I thank each and every one of you for attending and contributing to the success of this faculty development program. Let us take the knowledge and insights gained today and apply them in our respective fields to drive innovation and excellence. Thank you once again, and I wish you all the best. Thanks once again.
So I thank the participants first for their patient listening for about more than 2 hours, number one. Next, number two, I thank the management of Malla Reddy Group of Institutions for having me here and given the great opportunity to interact with all you people. Thank you very much. And if next opportunity has come for me, I will talk in another matter in the next level of talk with you people. Thank you very much.
Thank you, sir. Thank you so much.
Thank you. So, can I leave? Or?
Dear participants, yes,
please continue, John. Please, Sumit, please continue. Something that you are talking about.
Yes, sir. Thank you all the participants who are attending and join our faculty development program. There is small announcement. We have posted the feedback link in the chat section. It will open for 20 minutes. You have to fill the feedback link as well as in the YouTube link session also. There we also posted the feedback link. It will open for 20 minutes. Okay. So you need to fill the feedback form. Then we will provide you the certificates by the end of the day today in your WhatsApp group. Thank you, everyone. Thank you for success in our faculty development program. Thank you, sir.
Thank you, madam.
Have a great day ahead, everyone.
Thank you. You too, all of you too. Thank you very much.
Thank you, sir.
மேடம் இப்போ ஒரு சீட்டு உங்களுக்காக
स्टॉप रिकॉर्ड करना